transmission parameters or T parameter, also called as ABCD parameters. So the basic definition is T parameter means V1 I1 expressed as function of V2 and minus I2. That is input port parameters expressed as function of output port parameters. So in matrix form this can be written as V1 I1 equal to A, B, C, D, V2 minus I2, or V1 is equal to A V2 minus B I2, and I1 is equal to C V2 minus D I2. So these are the describing equations for T parameters. So in order to obtain A and C, we have to make I2 to 0. That is, we have to open circuit the output port. So the first case is, let's make I2 equal to 0. That is, let's open circuit the output port. So when I2 is equal to 0, A will be equal to V1 by V2, I2 equal to 0, and C will be equal to I1 by V2. I1 by V2 again at I2 equal to 0. So by open circuiting the output port, we will get A and C. Similarly, B and D can be obtained by keeping V2 equal to 0. That is, by short circuiting the output port. Short circuit the output port. And we will get B is equal to V1 by minus I2 at V2 equal to 0. Similarly, D will be equal to I1 by minus I2 again for V2 equal to 0. So these are the T parameters V1 I1 expressed as function of V2 minus I2. Next is inverse transmission parameters or T dash parameter, otherwise called as A dash, B dash, C dash, D dash parameter. It's just the converse of transmission parameter. Here V2 I2 expressed as function of V1 minus I1. That is output port parameters expressed in terms of input port parameters. So in matrix form we can write as matrix V2 I2 is equal to A dash, B dash, C dash, D dash into V1 minus I1, or V2 is equal to A dash V1 minus B dash I1, and I2 is equal to C dash V1 minus D dash I1. So to obtain A dash and C dash, we have to reduce I1 to 0. That is, I1 to 0 means we have to open circuit the input port. So we will get A dash is equal to V2 by V1 for I1 equal to 0. Similarly, C dash is equal to I2 by V1 for I1 equal to 0. So by open circuiting the input port, we get A dash and C dash. Similarly, B dash and D dash can be obtained by short circuiting the input port. That is, by setting V1 equal to 0. We have to short circuit the input port. So, B dash is equal to V2 by minus I1 for V1 equal to 0, and D dash is equal to I2 by minus I1 again for V1 equal to 0. So, inverse transmission parameters are V2, I2 expressed as function of V1 minus I1. Find inverse transmission parameters for the circuit shown. Now there are two ways to do this. Inverse transmission parameter means the basic definition is V2, I2 expressed as function of V1 and minus I1. So one method is you frame an equation for the given circuit for V2 in terms of V1 and minus I1. Similarly, frame an equation for I2 in terms of V1 and minus I1. And then you can compare it with the describing equations and write down the parameters A dash, B dash, C dash and D dash. Another method is you directly find out the values of A dash, B dash, C dash and D dash by applying the conditions, that is by setting I1 equal to 0 or by setting V1 equal to 0. So both ways we can do. Here I am going to show you the second method. So for that, let's write the describing equations. V2 is equal to A dash V1 minus B dash I1 and I2 is equal to C dash V1 minus D dash I1. So the first case is we have to set I1 equal to 0. Okay, so we'll draw the circuit diagram for that. So here V2 is the voltage source resulting in a current I2 and V1 is drop across this 2 ohm. I1 is set to 0. There is no current from the source V1. So to find out A dash, we can write the definition. A dash is equal to, what is A dash? V2 by V1. It is V2 by V1. Now what is V2? V2 is I2 into R effective divided by V1 is, suppose that the current flowing through this 2 ohm is say I3, then V1 will be I3 into 2, correct? Now what is R effective? 2 and 2 is in series, that is 4. R effective is 4 parallel 2. That is 2 by 3. So I2 into 2 by 3 divided by. Now what is I3 in terms of I2? I2 is the total current. When it reaches this point, it will divide into 2. I3 and another current. So what will be I3 in terms of I2? I3 will be equal to total current I2, total current I2 into opposite branch. Opposite branch is 2 divided by the sum 6. So this is equal to 2. Now same way we can find out C dash. C dash is equal to I2 by V1. I2 by, what is V1? We have already written it as I3 into 2, and we have written I3 in terms of I2. I2 into 2 by 6 into 2, which is equal to 6 by 4, that is 3 by 2. So C dash is 3 by 2. So we got A dash and C dash. Now we draw the second condition, which is we have to keep V1 equal to 0. So V1 equal to 0 means we have to short circuit the input port. When we short circuit the input port, that 2 ohm can be neglected. So the circuit will be just this. This is V2 resulting in a current I2. This is 2. This is 2. Okay. So what is B? B is equal to B, so B, not B, B dash. B dash equal to V2 by minus I1. Now what is V2? V2 is total current into R effective. R effective is 2 parallel 2, which is 1, into 1 divided by I1. What is I1? I1 is this current which flows through this port. So it will be total current divide equally. So I1 can be written as I2 by 2. But the direction is opposite. So the answer will be 2. That is, if you want, you can write it as minus of minus this. That is, the actual current is outward, but we are taking it as inward. So hence these two minus sign will get cancelled and we will get 2. Similarly, D dash. D dash is equal to I2 by I1. I2 by I1 minus I1 minus I2 by 2, which is again 2. Thus, the T dash parameters are A is 2, A dash is 2, B dash is 2, C dash is 3 by 2, and D dash is 2. So this is the final answer. Now the same problem we can do by writing the mesh equations and rearranging it to get in this form. In terms of V2 and I2, V2 in terms of V1 I1 and I2 in terms of V1 I1, we'll get the same answer. Find transmission parameters for the circuit shown. So here the circuit have a dependent source. Let's try the second method by writing the equations. Now this is the current flowing to this first loop and I2 is the current flowing to the second loop. So let's write equations for mesh 1. For mesh 1, the equation will be V1 is equal to 4I1 plus 16 into I1 plus I2, or this is equal to 20I1 plus 16I2. This is V1. Let this be equation number 1. Now we will write mesh 2. Mesh 2 will be V2 plus 8I1 is equal to 8I2 plus 16 into I1 plus I2. Or we will get V2 is equal to 8I1 plus 24I2. Correct? So this is equation number 2. Now, what are our describing equations? Our describing equations are, for T parameter we need to get V1 in terms of V2 and I2, and similarly we need to get I1 in terms of V2 and I2. Okay. So here we have I1, I2 and V2. So let's rearrange this. From equation 2, we can get I1 is equal to 1 by 8 V2 minus 24 by 8, that is 3 I2. This is equation number 3. Now this is in standard form, I1 in terms of V2 and minus I2. So we can compare this with the describing equation which we have written there. So from the comparing those two, we can write C is equal to 1 by 8 and D equal to 3. So this is one equation which we got. Now let's substitute this equation for I1 in equation 1. Substitute 3 in 1. We'll get V1 is equal to 20 into 1 by 8 V2 minus 3 I2 plus 16 I2. Or this is equal to 20 by 8 V2 minus 60 plus 16. That is minus 44 I2. So we got V1 also in terms of V2 and minus I2. This is also the standard form. Thus, comparing 3 and 4 with the describing equations, we can write matrix T is equal to A is 20 by 8, B is 44, C is 1 by 8 and D is 3. So this is the method by which we write the equations and compare it with the describing equations. Question: determine transmission parameters for the circuit shown. So let's do this also by framing equations and comparing with the describing equation. So the describing equation for T parameter is V1 expressed as function of V2 and I2. I1 also expressed in terms of V2 and I2. So we should frame equations for the given circuit in this format and compare with this to get A, B, C and D. So let's start by writing the node equation. Now this is V1, voltage at this node is V1 and the voltage at this node is V2. So let's write equation for node 1. So node 1 equation will be I1 is entering, so I1 is equal to V1 by S plus V1 minus V2 by 1, or I1 is equal to 1 by s plus 1, which is s plus 1 by s into v1 minus v2. Okay. So this is our first equation number 1. Now let's write equation for node 2. I2 is entering the node. So I2 is equal to V2 by 1 by S, that is S into V2 plus V2 minus V1 by 1, or I2 is equal to minus V1 plus S plus 1 V2. So here from this, let's frame equation for V1. Okay, what will be V1? V1 will be equal to S plus 1. Now let's write this. We will frame an equation for V1. V1 will be equal to S plus 1 V2 minus I2. So look here, we got an equation for V1 in terms of V2 and minus I2. This is the standard form. Okay. So let this be equation number 2 and this be equation number 3. So equation number 3 is in standard form. We get A and B from here. Now in this equation for I1, let's substitute for V1. So put 3 in 1. Then we'll get I1 is equal to S plus 1 by S into V1 is S plus 1 V2 minus I2 minus V2, or this is equal to S plus 1 the whole square by S V2 minus V2 minus S plus 1 by S I2, or this is equal to S square plus S plus 1 by S into V2 minus S plus 1 by S I2. So we got I1 also in terms of V2 and minus I2. This is again in standard form. So this is equation number 4. So 3 and 4 are in standard form. So we can write matrix T is equal to, what is A? A is S plus 1, B is 1, C is S square plus S plus 1 by S, and D is S plus 1 by S. This is the final answer.